Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. For some time, we've been on the series on set theory, and in this particular video, we're going to look at operations and sets. What are the operations we're going to be looking at? We're going to be looking at the union operation, the intersection operation, and the complement operation. So before we begin, if you have not subscribed to this channel, please hit the subscribe button below. And if you go on to like what we actually put out in this particular video, like the video. So let's get started. So the first thing we're going to be talking about is the union. What is union? So if I bring it to term, so two different people decide to marry, and the Bible says two shall become one, right? So in that same sense, union is the bringing together of two or more different sets and merging them into one particular set without repetition. So in line with what we've said, union is when you create a new set that combines all the items from two or more sets without any repetition. How do we denote it? We denote it by the symbol. It looks like as if it's you, but it's really not you, but I mean it's close enough to you. So if you use you, it's permitted. So mathematically, how are we going to express this? So when we have sets A, we have sets B, and we have the union between them. Remember this notation from the previous video where I was talking about singleton sets. So how do we read this? I said that you read it as X. This double column means such that. So it means that A union B is a set X such that X is an element. This E stands for elements. X is an element of A, or X is an element of B. So at the end of the day, this set, right, that we have here is going to contain elements X, right? And we can say that X will either be a member of A or it will be a member of B. Let's have some examples to bring this home. In the first example, we're told that set A is 253279 and set B contains 186410, and we're told to find the union between these two sets. Let's look at it together. So I could say A union B is, if I open its sets. So the best way I always try to do it is I always try to do it in ascending order so that I don't miss out anything. I could do it randomly and say 25379. Then, but it's possible that I miss out something. So let's do it in an increasing order. So if I look at A and B, the least value is 1, right? So the second least value is 2. Of course, there are two 2's, but there's no repetition in union. Then there is 3 from set A. Then there is 4 from set B. Then there is 5 from set A. There is 6 from set B. 7 from set A. 8 from set B. 9 from set A. 10 from set B. Is there another thing again? No, so 10 is the highest number. So when we have the union, it's just a union of numbers from 1 to 10 without any repetition. Let's see if we're correct. Great, so you can just see our answer is actually correct. Let's look at another example. So in this example, we're given a set A, which contains some days of the week, which is Friday, Saturday, Sunday. And set B contains 2 other days of the week, Sunday and Monday. And we're told to find the union of sets A and B. Pause the video and try it out yourself. Welcome back. Let's solve it together. So if I wanted to find the union of this is like saying A union B. I always try to start from the least value. So days of the week starts from the first day of the week is Sunday, right? So if I look at these two, there is Sunday in both of them, so I can just pick one Sunday, followed by Monday, then Friday, and finally Saturday. So I think that's it, right? So by the time you join these two guys together, you have Sunday, Monday, Friday. They can actually be in any order. I always just like to put it in ascending order so that I don't miss out anything once again. Let's see if our answer is correct. Yeah, so we have Friday, Saturday, Sunday, Monday. So the next operation I'm going to be talking about is intersection. What does it mean to intersect? So intersecting is really two things crossing together, right? So I'm going on my way, another person is coming on his own way, and then our paths join, right? Our paths intersect with each other. So let's say so we're trying to look at set A contains some particular elements and set B contains some particular elements. We say, oh, is there any point where what I can find in set A can find in set B? Let's look at the definition. So intersection creates a new set by identifying the common element that appears in 2 or more sets and is noted by this symbol that looks like N. How do we talk about this mathematically? So we say A intersection B is a set that contains elements X such that X is an element of A and X is an element of B. That makes sense, right? Because the element X must be a member of A and a member of B. So let's solve some examples that will bring this thing home. We're using our previous example, but in this case, we're finding the intersection. So if we have the set A and set B, what can we see that is common in both of them? So 2, 5, 8, 6, 7. Do you see anything common in both of them? No. Right. So that means that at the end of the day, there is nothing common in both of them. So how can we be able to express it? We can say A intersection B is equal to, can you remember how we said we denote an empty set? Great. So we either put an empty curly bracket, meaning that there's no element in it, or this sign, this phi sign. When somebody says this, knows that, oh, in set A and set B, there is nothing that joins both of them. There is no element that's common to both of them. So our answer here should be the null set. Great. Now, the next example is saying we have set A, Friday, Saturday, Sunday, set B, Sunday, Monday. What is the intersection between them? Obviously, we can see that if I look at these two of them, the only thing that is common in both of them, the only place where they intersect is Sunday. So our answer should be Sunday. Great. Now, the last operation I'll be talking about is complement. What is complement? Complement refers to the set of elements that are absent or not part of a specific set. So it refers to the set of elements that are not part of a specific set. Where we denote complement of a set, example, a set A is by saying A raised to the power of C, right? So anybody that says this knows that this is A complement or A prime. You can see the prime here. So I mean, if you're familiar with mathematical symbols, you know that this is prime. So A prime or A raised to the power of C. So what does that mean? It says mathematically A prime is X such that X is not a member of A. Let's see it with some examples. So this question says that we're given a U. This U is a universal set 1, 2, 3, 4, 5, and we're given set A to be 1, 3, set B to be 3, 4. It now says that we should find the A prime, the B prime, the A intersection B prime, and the A union B prime. Let's solve this together. So for the A prime, we can easily denote this and say A prime is what? So what is in the universal set that is not in A? Obviously, we can see that 2 is not in A, 4 is not in A, 5 is not in A. So our answer here should be 2, 4, 5. Our B prime will be what is in the universal set that is not in B. So we can see that it will be 1, 2, and 5, right? So let's put this. So that will be 1, 2, 5. The next question is saying that we should find A intersection B prime. Before we can find the prime, we have to first find A intersection B. So let's do that together. So A intersection B, where do they intersect? So if you look at this guy, the only place where they intersect is with the element 3. So I'll put that element 3 inside here. So A intersection B prime will be what is in the universal set that is not in A intersection B. Of course, we can see that this is going to be 1, 2, 4, and 5. So if I replace this, will be what? 1, 2, 4, and 5. Great. Now, the last question is saying that we should find A union B prime. Before we can find the prime, we have to first find A union B. So if I do A union B, that will give me what? 1, 3, 4. So A union B prime will now be what is in the universal set that is not in A union B. And that will be 2 and 5, right? If you look at it, that will be 2, 5. So this particular example sums up everything that we've been trying to do: intersection, union, and complement. Let's see if our answer is actually correct. So we have 2, 4, 5, 1, 2, 5, 1, 2, 4, 5, and 2, 5. If you compare side by side, well, we have this 2, 4, 5, 1, 2, 5, 1, 2, 4, 5, 2, 5. We can see that we actually correct. We've come to the end of operations in sets. In the next video, we'll be looking at set builder notation, where I was saying something like X such that X is so and so. We're going to look at that particular thing in depth. See you there.